contains 3 green, 5 blue, and 6 yellow marbles. I want you to do that one on your own right now. Do that on your own right now. What's the probability of selecting a yellow marble at random? Compound event. Joe, I'm not going to say it again. You can leave if it keeps going. Combines 2 or more events using words. So if you see these words, and, or, and you'll see what I mean when we get into this. That means that you add the events. So, yeah, and or. Let's say we want the probability of pulling a queen, and then we want the probability of pulling ace. So there's 2 different events. Okay? It's compound, 2 or more events using the words and or. Independent. With 2 events, if the probability of the first event does not affect the probability, shortening that, of the second event. So I have 10 dice in here, right? 4 of them are yellow. So I want to find the probability of pulling a yellow and then a red. So if, but I'm going to, probability of pulling a yellow would be 4 out of 10, right? So we pull that out, pull the yellow out. Don't put it back in. Now, if I don't put it back in, does that affect the probability of the second one? How does it affect it? Because it goes down to 9 to choose from, right? But if I put it back in, doesn't affect the probability for pulling a red because the denominator is the same, right? When it doesn't affect it, it's independent. An independent events. Okay, now dependent is when the probability of the second event is affected by the first. By not replacing. Okay, for these you would multiply, and we're gonna play with these a little bit. So multiply.
Is that one smiley face just like?
It's because it's an extra spot. Okay. All right, mutually exclusive. They're completely separate events. There's nothing that happens here that also happens here. So let's see what happens here. What's the event that first you roll a 3 and then you roll an even number? Make this a 2. This is a 2 here because it's kind of hard to read. Okay. Set A has 1 number. There's only 1 number here, right? And set B has 3 numbers. So we want to find the probability of rolling a 3 or an even. There's that word or. That makes it a compound event. So we're looking at it as 2 different events. 2 different events, a 3 or an even. That means that you have to add them. So this is your first event. And then you add to it the probability of your second event. We're not doing them all together. It's two separate things we're doing here. So that means we just add them together, the two probabilities. This is a 1 out of 6 pulling a 3, and a 3 out of 6 pulling an even number, or rolling an even number. There's 3 even numbers there. So we add them together, and it would equal 4 out of 6, which is 2/3. Looking for that word or is important. Or and. And it's just written like this. The probability of event A or B occurring is the probability of A, which we just figured out here, or plus the probability of B. Okay, let's talk about overlapping. When there's something that occurs in both of these events, here a 3 and a 5 happens in both spots. There's a 3 in set A and there's a 3 in set B. So, overlapping events. Set A has 3 numbers and set B has 3 numbers. There are 2 numbers in both of the sets. Probability of an odd or, there's that word or again, or a prime. Now, I'm adding the probability of getting an odd number, which is 3 out of 6, to the probability of getting a prime number. But the 3 and the 5 meet both of those requirements, don't they? So we can't count the probability of getting the 3 and getting the 5 twice. We have to subtract the overlap. That's called the overlap. Subtract any overlaps. Because we can't count the probability of getting a 3. Probability of A plus the probability of B, subtracting the overlap. Okay, let's practice this a little bit. Turn it over. You roll a number, cube. You roll a number cube. So we have one of these suckers, right? Oh, one of those things, sorry. Shouldn't say that word. We have a number cube. Find the probability of rolling a 1 or a number greater than 4. So there's that word or, which means I'm going to do what to the two probabilities? Add them together. So what's the chance of rolling a 1?
1 out of 6.
1 out of 6. I have to add to it the chance of rolling a number greater than 4. How many are there on this dice that are greater than 4? 2 out of 6.
What's the chance of rolling a 1, then a 2, then a 3, then a 4?
Equals 3 out of 6. I don't know, you figure that out sometime. 3 out of 6, which would be 1 over 2. 50% chance of both of those events occurring. All right, here's that word or again, so that means I'm going to add the probability. You do that one. Chance of rolling a 2, and then, or, the chance of rolling a 5. Shouldn't be too hard. What's the chance of rolling a 2? And then the chance of rolling a 5? There's only one 5 on a number cube. So that equals 2 out of 6, which is a 1/3 chance of that happening. Okay, what's the chance of an odd number or a number less than 5? Oh, wait a minute. How many odd numbers are on the dice? 1, 3, and 5, correct? How many numbers are less than 5? 1, 2, 3, and 4.
I said 2.
Okay, what do you notice? Wait a minute. Is there an overlap here for these events?
Yeah, 3. Yeah, 3.
1 and 3 are also odd, so there's 2 overlaps. Shh. So let's get through this. 3 out of 6 plus 4 out of 6 minus the overlap, which is 2 out of 6, which equals 5 out of 6 chance of both those events occurring. Okay? You cannot count the chance of these two occurring more than once, so you have to subtract them. Number less than 4 or an odd number. So what numbers are less than 4 here? 1, 2, and 3. Or an odd number, that's 1, 3, and 5. Is there overlap here?
Yes.
There's 2 overlaps. So first we do this probability. Plus 3 out of 6 minus 2 out of 6 equals what?
2/3.
I heard it. 4 out of 6, right? Which reduces to 2/3. So you have to consider the overlap. Overlap.
Oh my God.
Okay, almost done here. So wait a minute. This is using a compound, working with compound events. That was the first thing we talked about here. Compound. These are working with independent and dependent probabilities. Here's where you're going to start multiplying. So look at the difference here. An acceptable two-digit code made from digits 1 through 9 consists of an even number followed by an odd number. You choose two numbers at random. Find the probability that you've chosen an acceptable, reasonable code. So, 1 through 9 is 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm assuming you all know that in your math career at this point, all right?
No.
So for my first digit,
7,
I want an even.
4.
How many evens are here? So for my first digit, the chance of getting an even number is 4 out of 9. Does it say anything about not having a repeat?
I don't know myself.
So for the second one, it's, oh wait, no, it doesn't matter anyway because we're doing odd and even. For the second digit, I want an odd. So how many odds are there? Right. So I'm going to multiply it by 5 out of 9. This is all the same event. So it equals 20 out of 81. These are independent because this probability is not affected by this probability because this was odd and that was even. Okay, let's do another one. A bag contains 4 red, 5 green, and 2 blue marbles. You randomly draw 2 marbles one at a time. Find the probability that both are red if you replace the first marble. So just like I was doing with Jacob. When we put that dice back in, it didn't affect the second probability, did it? So here we're replacing the first marble. So it's going to be the same kind of situation. How many red marbles are there? 4. How many total marbles are there? 4 plus 5 plus 2. 11. 11. We need a total when we do probability. So, the probability that they're both red. So on the first draw, what's my chance of getting a red? 4 out of 11. Then I put that marble back in. And on my second draw, what's my chance of getting a red again? 4 out of 11, because that red one is still there. Still have 11. 16 over 121. Alrighty. Now let's see what happens when you don't replace that first marble. So, again, on my first draw, do not replace. So we're not replacing it. The first draw, we still have, they're all in there now, we have 4 out of 11 chance of getting a red. We don't put that red back in. So how many reds do I have left?
3.
Out of how many total? Right on. 12 over 110. 6 out of 55. Now, this is independent because the second event is not affected by the first. I didn't spell that right, but you know what I mean. Independent. I forgot the dent at the end. Independent. Yeah. This is dependent because the second draw is affected by the first. Okay?
Oh.
It depends on what happens with the first. Yeah, the second one's dependent on the first. Okay, let's do one more. You got to read these a little bit. I know you love to read.
No. See, that's where you're wrong.
A bag contains 4 marbles and, wait, 4 what?
Maybe we just shouldn't do
4
it.
blue marbles and 8 yellow marbles. You choose one marble at random. You do not replace it. and then choose a second marble at random. What's the probability that both marbles are blue? Okay, so I still need a total. What's my total?
12.
Yeah. On the first draw, what's my chance of pulling a blue on the first draw?
4 out of 12.
Right on, 4 out of 12.
Right out.
Do I put that one back in?
No.
So then, it's the same kind of problem. How many blues do I have left?
3 out of 11.
3 out of 11. Yep.
4 times 3.
Equals 12 over 132, which is 1 out of 11. And is this dependent or independent?
Dependent.
You guys got it.
Dependent.
It's not.
Depend.
Keeping track here when you're doing this homework, you're doing two different things. Compound events, look for the word or. Okay? And then you add the probabilities. Here it's the same kind of situation where you just multiply them together. Here's your homework. You ready?
Oh.
Ready or not?
Here I come.
I have two different homeworks here.
I was thinking, stop.
Amanda knows.
Lexi.
So this is some homework here, but it's review. It's not too bad.
Quite bad.
It's pretty bad.